Hello everyone, welcome again to my channel. Today we will learn how to estimate solar power potential on suitable rooftop using ArcGIS software. So at the end of this tutorial we may able to calculate area solar radiation, identify suitable rooftop and estimate electricity production per building rooftop. So open your ArcGIS software. First I am loading my data. This is my digital surface model and this one my building footprint. Before starting the calculation process, go to the area solar radiation tool help. One important thing that I want to show you is that it is recommended to have your data in projected coordinate system with unit of meter. Here I already project my digital surface model. Here the XY unit, linear unit in meter. Actually here the XY and Z values are in meter. So before calculation, first I will create hill shape so that we can clearly visualize the building rooftop, trees and other feature as well. For this, go to image analysis, select my DSM raster, add function. Here insert function, it will be hill shape. After that click OK. Now select your hill shaped raster, go to the properties, display and transparent it to 40%. Click on OK. Turn on this building footprint. Now we can clearly visualize the building rooftop, trees and other feature as well. So let's start the process. Click on this area solar radiation. This tool take into account the position of the sun and the light blocking obstacle that can be building, trees and the north facing surface of the building. Here the input raster, it will be your digital surface model, and the output raster type here name solar radiation, and the unit of this raster will be watt hour per meter square. Save it. Keep this value as default. As I want to calculate the solar radiation within a specific year, so this will be my desired year. The hour interval, this is the default value. In order to reduce the calculation time, I am choosing 1. From the topographic parameter, calculation direction, this is by default 32. So by default this tool checking the light blocking obstacle at 32 different directions around each cell. In order to reducing the calculation time, I am choosing the value 16. You can also use this value also. Now from the environment setting, I will mask the raster layer with building footprint, so it will only consider the building rooftop. It will also reduce the calculation time. After that, click OK. It may take 20 minutes or 90 minutes, so you have to wait until the process done. Okay, this is our solar radiation raster, where the unit of this raster value is in watt-hour per meter square. Now reduce the size of this value so that it will be easier to read. For this, go to the raster calculator, select the raster divided by 1000, and the output raster will be solar radiation raster, but it will be kilowatt hour per meter square. Then save. After that, click on OK. Here the raster cell value is in kilowatt hour per meter square. Changing the symbology from here. Okay. Now we will identify suitable rooftop. For this, first we will create slope. Go to here, surface, then select slope. The input raster, it will be our digital surface model, and the output raster will be the slope. Click on save. After that, click on OK. This is our slope raster. Now create aspect raster. Input raster will be digital surface model. Output raster, type here aspect. Click on OK. First, I will work with slope raster. To identify suitable rooftop, I will consider these three conditions. First one is suitable rooftop should have a slope of 45 degree or less, as steep slope tend to receive less sunlight. Okay, let's find out the slope that is less than 45 degree. For this, go to conditional, select this one condition. The input raster, here input raster will be slope. In the expression, type here value that less than and equal 45 degree. Click on OK. So from the slope raster, it will only take those value that are less than and equal 45 degree, and those value will be changed using the corresponding value of this value. And the input false raster, keep it as default, and the output raster, this will be our condition 1 raster. After that, click on OK. Now close this one. From the slope raster, it will only take those values that are less than or equal to 45 degree, and those values are replaced by the corresponding value of this solar radiation value. We will consider our second condition, that is the suitable rooftop should receive at least 850 kilowatt hour per meter square of solar radiation. In order to meet this condition, go to the con tool again. The input conditional raster, this is our first conditional raster, and the expression type here value is greater than and equal 850 kilowatt hour per meter square. The input true raster will be our conditional 1 raster. Type here solar radiation high solar. Click on OK. The third condition is suitable rooftop should not face north, as north facing rooftop in the northern hemisphere receive less sunlight. So from the aspect raster we know this value and this value are north facing, so I will remove this value. We also want to keep the flat surface, so for this open the con tool again. Let's extract flat surface from the slope. Type here, we can say if the value of the slope is less than 10 degree, then that can be flat surface. And the input true raster, the output raster value will be replaced by the value of this raster. Name the output raster as flat roof, then click on OK. Open the con tool again. Now use the aspect raster. In the expression type value that is greater than this one, 22.5, and value less than 337.5. so it used the aspect raster and remove the value range. The rest of the value will be replaced by the corresponding value of this raster, and it also keep the flat roof. Output raster, name the output raster as suitable cell. Click on OK. So here we meet both two conditions. It removed the north facing rooftop and also keep the flat roof. Click on OK. Now open the building footprint attribute table, add field, name here building ID, type is the long integer, field calculator, FID plus 1. Click OK. I will calculate for every building the total area covered by a suitable cell and the average solar radiation. For this I will use zonal statistic as table. So open this tool, the input raster or feature zone data, select the building footprint, zonal field as building ID, input raster, select this one, suitable cell, and the output table, name the output table, save it. In the statistic type I'm choosing mean. Now click OK. Close it, open the table. So now for every building it calculates the area covered by a suitable cell and the mean solar radiation received by this building rooftop. Now open this building footprint attribute table, join this table with this data, choosing the field in this layer that the join will be based on. The join will be based on building ID, choosing the table, keep only matching record. For that click OK. Now for installing solar panel we need minimum area. Let's say the minimum area is 40 square meter in order to install solar panel on the rooftop. So I only select the building that have the area greater than or equal to 40 square meter. For this, select by attribute this one, area is greater than and equal 40. After that click on OK. Export the suitable building for installing solar panel. Building, save. Uncheck this one. So this will be our suitable building for installing solar panel. Open attribute table again, add field solar radiation, make it as float. Now we will calculate the amount of solar radiation within this area. For this, open field calculator, the area multiplied by the mean solar radiation. So this will calculate the total amount of solar radiation received by this rooftop, where the area is this one, and dividing this value by 1000 so that the output value will be in megawatt. Click on OK. So we can say that this building can receive 147 megawatt hour of solar radiation within this suitable area. Now create another field, that is electricity production. Type here float. As today most of the solar panel provide an energy efficiency rating between 11 to 50%. which is the percentage of solar energy that is being converted into usable electricity, and then 86% of that electricity is preserved as it goes through installation. So from the field calculator, remove this equation, select this usable solar radiation multiplied by the efficiency of solar panel. Let's assume this value as 15%. This is 15% efficiency of solar panel that can convert the solar energy to usable electricity, and multiplied by 0.86. Actually this one, 86% of that electricity is preserved. After that, click OK. So we can say that if we install solar panel on this rooftop, it can produce 19 megawatt of electricity. And if we consider this whole neighborhood, we can say that this neighborhood can produce 6,482 megawatt of electricity in the year 2022 if solar panel is installed on its building rooftop. So I hope you like this tutorial. You can consider subscribe if you like this tutorial, and thanks for watching.